Hello and welcome to Math 200 Online Statistics here at Cañada College. My name is Lapuz. We will be working on a homework problem using Google Sheets. Here's our problem. They want us to find the mean of the data summarized in a given frequency table. They want us to compare the computed mean to the actual mean of 56.1 degrees. So let's go ahead and copy this onto a clipboard and bring it to Google Sheets. We have our table of values. Now we have classes here, and these classes are not exactly this numerical data that we want. And we have the frequencies here. So what we essentially want to do is recopy the frequencies, and I'll put it just a couple of columns away. We'll call this the frequencies. And now what we need here is, instead of range of values like 40 to 44, we want a good representative. And the best representative would just simply be the middle value between 40 and 44. Now, if this turns out to be some complicated numbers, we might want to do the computation in Google Sheets, since we have the power to do that. And in order to do that, we have to add those two values, and we're going to divide it by 2. So we're really finding the midpoint or the median or the arithmetic average. So that's 42. Now if you notice, we go from 40 to 45, looking at the lower class limits, or the upper class limits from 49 to 54. And we have to note that the difference between these class limits look like they're 5. So 54 minus 49, for example, is equal to 5. So what we can do is take advantage of the power of a spreadsheet and take our number and add 5 to it. And so the good representative for the second class is 47. Now if I just take this, click on the cell, and grab it by the lower right hand corner and drag it down, it will autofill with a formula of adding 5 to the previous cell. And so now we have the class representatives. Now what we want to do to find the average is we want to multiply x times f. And so, again, taking advantage of a spreadsheet, we can just say equals this number times this number. And it turns out that 42 times 3 is 126. Now we can click on that cell, grab it by the lower right hand corner, and drag. And now we have the products of these values. So far, so good. We want a couple more things. What we need is we need to add sum of all the frequencies. So we'll place the sum of all the frequencies in this slot here. So let us say equals sum, open parentheses, and then click and drag the range that we want, and close parentheses and enter. So that's 25. And now in this slot here, I am interested in computing the sum of f times x. So the sum of all these values here. Alright, so I'll say sum, open parentheses, and then click and drag, and then close it. Finally, the mean is going to be the division or the quotient of these two numbers. So I'll say equals, and then I'll click on this number. That's 1285 divided by 25. And we'll press enter, and this is 51. So if you look at this distribution, it looks pretty bell-shaped. It starts off low, 5, 3, 5, 11. It peaks at 11, and it goes back down. So I would imagine the average would be somewhere in the middle, like between 50 and 54. And average of 51.4 seems like it's good. Okay, let's go back to that assignment and see if that's correct. Well, let's first put a wrong answer in, just to show you what the formula is. So here's the formula. It's the sum of f times x divided by the sum of f. All right. So now that we know that formula, let me take a peek again. 51.4. So let's put the answer 51.4, and that looks good. The next question is asking if the following describes a relationship between the computed mean and the actual mean. So the computed mean is 51.4, the actual mean is 56. Does that seem like it's close? They're measuring the closeness, asking if it's within 5% of the actual mean. The difference is within 5% of the actual mean. So I might be interested in taking the difference here, 56.1 minus 51.4. Let's go back to our Excel sheet, and let's say equals 56.1 minus our mean that we found, 51.4, and that's 4.7. Now let's divide 4.7 equals 4.7 divided by the mean that they found, which is 56.1, and that is 8.3%. So it looks like it's bigger than 5%. So if it's bigger than 5%, according to them, it's probably not very close. So the mean is close to the computed mean is close to the actual mean because the difference is more than. So I think it's not close because it's more than. And I think that combination happens in D. So let's click on D. Check our answer. Okay. So that's this problem. I hope that helps.